Hello, assalamualaikum. So I'm so sorry. I just prepared this video for today's lesson. Okay, so our subtopic today is qualitative analysis, the last subtopic for salt. Okay. So what you all have to know is these two learning standard. Okay. Okay, look at these two learning standard. One is to identify the cation and anion present in the salt through experiment. Through experiment. And another one is describe the confirmatory test to identify cation and anion. Okay, so this qualitative analysis is actually to predict what are the cation and anion present in a salt. Let's say you are like a forensic scientist. Okay, you are given a sample of salt that is unknown. Then you have to finally determine the cation and anion present in the salt. Okay, so what is qualitative analysis? Qualitative analysis is a technique used to identify the cation and anion present in a salt by analyzing its physical and chemical properties. Okay, so the steps involved are this one. Observation on the physical properties of the salt. Okay, effect of heat on the salt. This one we have learned in previous subtopic. This one as well. Okay, test for anion and cation, and the last one is confirmatory test for cation and anion. Okay, so let's see one by one. The first step is observation on the physical properties of salt. This one include physical properties, the solubility of salt in water. This one you have learned earlier, whether the salt is soluble or insoluble in water. And then the color of the salt. This one is the first step. Let's say like this, you are given a sample of salt. This is a packaging sample of salt. Okay, this is salt. So the first step is you record the color. What is the color? Mostly salt are white in solid and white solid, but when dissolved in water it produce colorless solution. Mostly salt are like that, but there are a few salt that has color. Copper to salt, copper to chloride, copper to nitrate, copper to sulfate salt. Okay, it is blue in color. Iron to salt, iron to ion salt. Iron to ion. Okay, iron to ion, like let's say iron to chloride, iron to nitrate, it give green in color, and iron 3 is brown. Okay, copper to ion is blue. Means if the salt contains copper to ion, copper to chloride, copper to nitrate, so it is blue. Except for copper to carbonate. Copper to carbonate is green in color. Okay, so only this salt give color. Okay, other salt, sodium salt, potassium, ammonium, zinc, all of the salt are white, white solid. Okay, so that's the color. And the solubility, you just take a sample, maybe 1 spatula of salt, and put it in a test tube, and then put water, and then stir or shake, and you'll see the solubility. Okay, next is this one is like I mentioned before. Okay, this is the color mentioned just now, the color. Okay. This is the step to see the color, the solubility. Okay, second step in analysis qualitative is the effect of heat on salt. We know that salt will decompose when it is heated. Okay, so after the salt is decomposed, this is the activity, the experiment, how the salt is heated. Okay, this solid salt, solid salt, and then it is heated. Okay. Okay. Before we have learned that after the salt is heated, it will produce a gas. Okay, and then the solid salt will remain as residue. Okay, like I mentioned before, mostly salt are white in color. So if white salt after heated, it will produce white residue, but only a few residue has color here. In subtopic 6.10, you have learned this. Okay, only this a few salt will give colored residue. The residue is oxide metal. The residue is oxide metal. Okay, if the color of residue is black, so it contains copper 2 ion salt. If the color of residue is brown, so it is iron 3 salt. If the residue is yellow when hot and white when cold, so it contains zinc ion. If the residue is brown when hot and yellow when cold, so it contains lead 2 ion. So you have to memorize this. Okay, and then this is the test for gas produced. Okay, so we have 8 different type of gases. So here we have some for carbonate salt. If it produce carbon dioxide salt, if it is the salt after heated produce carbon dioxide, so it is carbonate salt. So the carbon dioxide gas turns lime water cloudy. This is the test for gas. Gas is brown and acidic. This is nitrogen dioxide gas. So nitrate salt produced. Not nitrate salt produced. So the nitrate salt is the salt that it is heated. Okay, if the gas produced is pungent and alkaline. So the pungent gas is ammonia gas. So it is ammonium salt. If the gas ignites the glowing wooden splinter, means this is oxygen gas. So the salt might be nitrate salt or silver carbonate. Okay, so this is effect of heat on salt. Okay, this is the example. Second example. Okay, the third step is anion and cation test. Okay, anion is the negatively charged ion in the salt. Okay, so we have anion here, carbonate ion, sulfate ion, chloride ion, and nitrate ion. Okay, so this ion can be identified by using a certain reagent. Okay, so what are the reagent to test this ion? Okay, if the ion is carbonate ion, but we don't know what is the anion present in the salt, so you have to do all these tests. So you have to take a sample of salt and then put it in a test tube, put some water, and then add. Okay, for carbonate salt, you add dilute acid, any acid. Maybe for carbonate you can use nitric acid or hydrochloric acid, any acid actually. Okay, so if it is carbonate salt, it will produce, when react with acid, it will produce a gas that turns lime water cloudy. This is actually what gas? Carbon dioxide gas. Acid react with carbonate salt, let's say zinc carbonate or calcium carbonate. So it will produce carbon dioxide gas. Then the carbon dioxide gas will turn lime water cloudy. So you just add any acid. For chloride salt, you use dilute nitric acid and silver nitrate. You add these two reagents, so it will produce white precipitate. So if white precipitate present, then the salt is chloride salt. The anion present is chloride ion. Okay, for sulfate ion, you add dilute hydrochloric acid and barium chloride solution. It will give white precipitate. Okay, for nitrate ion, you add dilute sulfuric acid, iron to sulfate solution and concentrated sulfuric acid. A few drops, just a few drops of concentrated sulfuric acid. Okay, it will produce brown ring. Okay, these are anion test. Okay, this is the experiment for anion test. See, test for carbonate, for chloride. Okay, for experiment, you just see the molarity. Okay, and here are the reagent just now. Okay, for nitrate salt. Okay, next is cation test. Cation test. For cation test. Okay, for cation test. So cation is the positively charged ion of the salt. So this is the experimental steps. Okay, I don't want to discuss that one. I want to show this flow chart. Okay, so you can use two reagent. One is sodium hydroxide, this one, and another one is ammonia solution. Okay, so let's see the first one, sodium hydroxide. Okay, so now you have salt solution in a test tube, and then you want to test the cation present in the salt. Okay, so you add a few drops of sodium hydroxide solution, and then observe, does precipitate form? Okay, if no precipitate, then it is hit the mixture, and if the it produce a gas, then you test a gas with red litmus paper. If the red litmus paper turns blue, so ammonium ion present, means that one is ammonia gas. Okay, so the cation present in the salt is ammonium ion. If there is no precipitate, there is precipitate, you add sodium hydroxide solution into the salt. If precipitate form, then you observe the color of precipitate. If no color, no color means white in color. Okay, if it has color, what is the color? If blue, so copper to ion present. If brown is iron 3 ion present. If green, it is iron 2 ion present in the salt. Okay, if there is no color, means it is white. Okay, white. So what you have to do is you dissolve with excess sodium hydroxide solution. You add more sodium hydroxide solution. Okay, if the salt dissolve in excess sodium hydroxide solution, dissolve, so the cation present may be pizza, pizza, P Z A, lead, zinc, aluminium, pizza. Okay, if there is no precipitate when you add this excess sodium hydroxide solution, no precipitate, it not dissolve, so it is Mc, magnesium calcium ion present, pizza Mc. Okay, another one. If you test with ammonia solution, same thing. Does it form precipitate? If no, so the ion might be present is calcium ion and ammonium ion. If yes, there is precipitate, so you observe the color. If it has color, copper to ion, if copper to ion present, so it will give blue color. If green color, so it is green, green. Green color, it is iron to ion. Brown color, it is iron 3 ion. If the precipitate form is white, no color white. So you add excess ammonia solution. If it dissolve in excess ammonia solution, the salt just now dissolve in excess ammonia solution. Okay, so the ion present, the cation is zinc ion. If not dissolve in excess ammonia solution, it may the cation might be magnesium, aluminium, and lead to ion. Okay, just now pizza, Mc, this one is zinc matte. Zinc dissolve, matte not dissolve in excess ammonia solution. Okay, so this is example. Okay, and the last one in analysis qualitative of salt is confirmatory test for cation. Okay, so you have a few tests for cation. Okay, this one I use this flow chart. Okay, so the test only for ammonium ion, iron 2 ion, and iron 3 ion. Kita ada banyak cation, but the confirmatory test only done for these 3 ion. Okay, so if ammonium ion present, we use Nessler reagent, add into the salt, and what happen is brown precipitate form. If iron to ion, you use potassium hexacyanoferrate 3, dark blue precipitate will form. If iron 3 ion, you use potassium hexacyanoferrate 2, dark blue precipitate, or you can also use potassium thiocyanate. It will give blood red solution. Okay, so I think that's all for the confirmatory test, and this one another one, confirmatory test for aluminium and lead to ion. Okay, you use a few drop of potassium iodide solution and observe if there is what is the color produced. If there is yellow precipitate, next is you heat the mixture, and if the yellow precipitate dissolve in water, it produce a colorless solution. So and the yellow precipitate form again after cooling, so the cation present is lead to ion. Okay, if there is no precipitate form, when you add potassium iodide solution, then it is aluminium ion. Okay, so this one is the flow for the analysis qualitative. Okay, and there is a lot of experiment here. Okay, so that's all for today's lesson. I know there's a lot of things you have to memorize in this subtopic. Okay, so that's all. Thank you. Bye.